I'm Matt Jarvis, I'm the Head of Cloud Computing at Datacentred, and I'm going to give you a very brief overview of the open source technology stack we're using to build out our shared services infrastructure. For those of you who were at the last meeting and saw our Chief Executive's presentation, you may already know this. We're a co-location and cloud startup based in Manchester. We're currently building out our first site around the corner from Media City, UK. As we just said, I've only got 5 minutes, so there's not much time to go into any technical detail. But we are around for the rest of today's session if you'd like to know any more. So this is one view on what it takes to do cloud computing, but the reality of building scalable on-demand platforms is possibly slightly more complex. Building these kinds of architectures even 5 years ago would have been a major undertaking, required very significant resources in terms of development and time. But more recently, a number of open source projects have come to fruition, which taken together make up the building blocks to create scalable multi-tenant infrastructure. Openstack is probably the most well-known of these tools. It's an orchestration framework for building hyperscale multi-tenant clouds from commodity hardware, which handles all the lifecycle management, networking and storage. It allows customers to provision and deprovision virtual machines, create complex virtualized networks with routing and IP management, and manage persistent storage volumes all through a web-based GUI or via an API. We chose Openstack for a number of very compelling reasons. Because it's open source, we're not locked into any proprietary vendors, and we also don't have scaling licensing costs. But more importantly, having access to the source code and using open standards means it's much easier for us to integrate and extend. It's a proven technology already, very many large-scale public and private clouds running it, and there's a very active user community. And it's also under very active development, which is really one of the key metrics for open source projects. More than 75 leading technology companies now have engineers contributing to Openstack, and the pace of development is accelerating and the feature set's growing with every release. Moving on to storage, we're building a distributed object store, similar architecture to most of the web-based storage providers, and we're using this very cool piece of software, Ceph, which allows you to build very large storage arrays using commodity servers. Ceph provides API access, which is fully compatible with the Amazon S3 API, so any applications that are using that can also use Ceph. And it also allows us to provide block volumes and file system access, which are layered on top of the underlying object store. So using Ceph means we can build out a single unified storage architecture, which is highly scalable and is all managed through a single interface. In order to be able to manage potentially hundreds or even thousands of machines without having a similar number of system administrators, we also need a highly automated management stack. This really breaks down into these 4 key areas: provisioning, configuration management, orchestration and monitoring. And in each of these areas there's some very powerful open source solutions, some of which are already industry standards and I'm sure you're familiar with. This slide just shows a few of the pieces we're using. I'm not going to go into any detail here, but what this all adds up to is this concept infrastructure as code. Everything we do from a systems management perspective is effectively a development activity. We don't administer individual machines, we write code that creates state, and then we ensure that that state is maintained. Everything is treated in exactly the same way as a development project. We use version control, we have a development process, and we rapidly deploy changes through testing and staging into our production environments. So finally, I'd just like to give you a couple of potential use cases within the collocation space for these kinds of shared services. At the most basic level, a number of different but very well understood workload types which fit very well into the on-demand model. We have situations where service use is growing rapidly and it's difficult to keep up with the hardware requirement. Batch type workloads where the customer would otherwise have to over-provision capacity that's wasted for a lot of the time. There are unpredictable workload spikes where you don't want to over-provision for the extreme case. And there are the fairly predictably peaky workloads which again would cause wasted capacity if those trends are only periodic. And in all those cases, having access to on-demand infrastructure is a potential solution for our customers. On the storage side, many organizations are seeing a huge rise in the requirement to store data. We're creating far more data, and there are compelling reasons to keep that data around, both from a commercial perspective in terms of extracting value through analysis, and in terms of regulatory requirements. So in both of those cases, having access to low-cost bulk storage is extremely attractive, and we're seeing customer demand across many different sectors. So that's an incredibly breakneck overview of the tools we're using to build out our infrastructure. And some potential use cases. This is not by any means the only way to do things, either using open source or proprietary solutions. But for us, the great thing about the open source toolset is that you really have the flexibility to integrate in any way you need to solve your particular problem. So thank you for listening.